Good afternoon, everyone. We are Group 6. Our topic is solving the prisoner's dilemma game through a top down approach and self governance. There's a hypothetical village called Jailpur in which there are common pool resources such as a forest, pond, and grasslands. For simplicity, let's consider a forest. In the village, the forest resources are used by the villagers for making houses and furniture and for other purposes. To simplify the game, let's consider that there are two players, a plunderer and a conserver. Now let's first understand what is the prisoner's dilemma game. The prisoner's dilemma illustrates how individually rational people can collectively do irrational things and has vast applications across the social sciences. The general characteristic of the prisoner's dilemma game is that it consists of two or more players who are able to engage in either cooperative or defecting types of behavior. Each player benefits from the cooperative play of others, but individually has an incentive to defect. The prisoner's dilemma game is rich in irony because each player is better off defecting regardless of the behavior of others. The game yields a unique Nash equilibrium in which all defect and are worse off than if each player had played cooperatively. More agreements between players not to defect are notoriously difficult to enforce, particularly in one-shot plays of the game. No matter what they agree to do, each player knows that at the end they will be better off by defecting. Therefore, each does defect to the detriment of others. In this regard, the prisoner's dilemma game represents a divergence between collective and individual rationality.
If in Jailpur there are law and order concerns and everyone is acting in self-interest, then the village will fall in the prisoner's dilemma trap. As you can see here, R depicts the payoff to the plunderer. S depicts the payoff when everyone is conserving. T depicts the payoff when everyone starts plundering. This is the tragedy of commons. V depicts the payoff when one player is conserving and the other is plundering, and vice versa. With the payoffs ordered R greater than S, S greater than T, and T greater than V, the game forms a prisoner's dilemma, and as shown in the matrix, the Nash equilibrium in a one-shot play of the game is regrettable. If everyone in Jailpur is acting in self-interest, then it will lead to a collective loss of resources. There are ways to avoid this trap, which will be explained by my teammates.
One possible method of preventing this trap is by using the top-down approach by a strong central state. In such an approach, the state appoints a forest officer to penalize the village for plundering. Now let's introduce the concept of expected fine small f. Expected fine depends on the two parameters. First, the value of fine, that is the capital F, the probability of being caught by the forest officer, that is small m. So the equation will be F is equal to m into F. Let's consider the case 1 where the expected fine is low. Expected fine is low in two scenarios. First, if the fine value imposed by the state is low. Second, probability of being caught is low. This implies the number of officers hired by the state is less. Then conserve will be the Nash equilibrium. But it won't be the unique Nash equilibrium. If the expected fine is low, then we can't escape the prisoner's dilemma trap completely. We can see this from the matrix also. Now let's consider the second case where the expected fine is high. So in this case, conserve will be the unique Nash equilibrium. We can see this from the matrix also. These situations will certainly help in escaping the prisoner's dilemma trap, but it has many practical implementation challenges. The challenges increase when it comes to India. For an example, we can think about the case of Amended Motor Vehicle Act 2019, where if person could not produce his driving license, then the fine imposed was as high as 5,000 rupees. So fine was high, and this case led to reported cases of corruption also.
Consider the case when a local self-government replaces the strong central government for the monitoring purpose of the common pool resources in the Jailpur village. And let's assume that the cost of monitoring is high enough. Then it will lead into two nice equilibriums where one is plundering while the another one is conserving. But this case will not enable us to get freed from the trap of prisoner's dilemma. Now, the local government can reduce this cost of monitoring by employing local people who are well versed with the area and can identify the potential loopholes where the plundering can take place. If the cost of monitoring has been reduced, then this will make the conserve strategy as the unique Nash equilibrium and will finally help us to escape the prisoner's dilemma trap. Therefore, this is the most feasible solution which can be implemented in the Jailpur village. And this has already been implemented and tried successfully in the Kottapalli village in Andhra Pradesh by the local self-government. Thank you.